Welcome everybody to our talk on infrastructure as code. Before we're going to start with the presentation itself, we're going to introduce ourselves, and we're going to start with Prajeesh over there.
Hi, welcome everybody. My name is Prajeesh. I'm a continuous delivery consultant working at Prajeesh. My job is mainly to help the teams to continuously deliver value to the end users. What I'm going to do today is, with Maarten, we are going to talk about some of our experiences about infrastructure as code, how I reached into this point, so some history back into the time and all those things. And after some theory and talks about it, I have a very small demo prepared for it. It's not like real production environment, but what I'm going to do is that I have this big, huge laptop over here, really high, and I have installed all the stuff on this one. The configuration of this laptop is in code, so I'm going to show you how I did that, and we can see how infrastructure as code works on a Microsoft server. Cool.
All right, thank you.
I'm
Maarten Kossen. I'm also a continuous delivery consultant or technical agile consultant, or whatever that means. We give trainings and we do coaching at some of our clients' places in Scrum, agile methodologies, DevOps, infrastructure as code, all that kind of thing. So who's the crowd? I'm wondering who you guys are. By a show of hands, who of you is a developer here?
Oh.
That's a very big crowd.
Nice.
Good. That's a good crowd. Who of you is operations? Wow, that's pretty decent as well. And who of you is a manager? Wow, that's, yeah, really outnumbered. Cool. And who of you hasn't raised his or her hand right now? Yeah, so what do you do, for example? Nothing. We'll get into that. All right, this guy doesn't want to share. All right, cool. So, welcome everybody. Infrastructure as code. I guess everybody knows what infrastructure as code means, and if not, we're going to show you what it is. This is a vision. Just read this part for a second and let it sink in. This is the vision we have set out, like this is what infrastructure as code should result in, like the total ability to reestablish a business just from source code, from a couple of backups, and bare metal resources. So envision this, you have like a fully functioning company, like ProAwareness with a website and everything, and all of a sudden the data center you're in is totally burned down, every client is down, and you're in big trouble. You're going to call LeaseWeb, of course, and you're going to say, look guys, we need some bare metal resources. You go over there with your source code, run all your source code, all your code that actually configures your infrastructure, put back the backups, and you're back online. That's a vision we put out here for infrastructure as code. That's what you actually want to achieve.
Who has that in your workplace? Oh, that's cool. Nice, too.
Just 2 people out of the 100 or so here. Okay, so you guys have a long way to go. So why would you want infrastructure as code? Look at this picture. There's the business that gives like an assignment to the development teams, and those are like Scrum teams, Save, they use XP. They have like all the tools they need to really rapidly create releasable increments of software. But then there's the operations guys that actually have no tooling whatsoever. They still need to do everything manually. I don't want to insult any of the ops guys, but I've actually seen some people that are systems management. They are just leaning on the enter button the entire day, running installers. I don't think that's a fun job to do, right? Don't you agree? That's like boring. There's a lot of better stuff to do if you want to be bored all day long. And so with infrastructure as code, we want to give the operations people the tools they need so they can actually match up to the development teams who have all these tools and practices. And that is what infrastructure as code is all about. Do you guys know any other advantages of infrastructure as code, as defining your entire infrastructure in a source code repository? Who wants to give a suggestion? You could do pull request. That's an advantage as well. Yeah, something closer to home, like a major advantage of infrastructure as code. I didn't hear that quite right, but can somebody yell that to me? Version control. Yeah, that's we should have used the throw box. Yeah, version control is amongst other things. And the cool thing is that you can actually have a version of your infrastructure in that source control that matches a certain version of your software. Other advantages are the fact that if you have your infrastructure defined as code, you have actually documented all of your infrastructure in that code. You don't need much other documentation in that. And it really allows you to rapidly move along, to scale rapidly, because everything is just a script, basically.
Well, I'm going to tell you about how, in my experience, I'm working with a customer now, where we bought this concept of infrastructure automation, of infrastructure as code into the project, why we did that one. This is a story somewhere 3 years back. It's not recently. We are not doing it now. We have done it now. So how we reached into this state. Basically, what happens is, when we started defining our applications, we want to deploy some applications into production and things like that. We want to create a production environment. The first thing which we did was, we sit together, had a workshop or a session where we defined the topology. What kind of farm we want in production, how many servers we want, what could be installed on the servers, how do we define scalability, that kind of discussions, right? You define the topology, and once we have that kind of thing, the next thing we did is somebody has to document this topology. So we create a technical design. It's probably everybody knows this kind of work. Created a technical design, and then it's time for somebody to really implement that technical design into one of the servers, right? So that's the manual work which is going to happen. And this is an example of our environment. So we started with something like a typical 3-tier environment. We had a web front-end server where we had our websites and all those things was targeted to. We had an application server where we ran our services. This was the business logic which was executing, that was providing data to the web front-end. And then, obviously, we had a relational database system over there. So it was a DB server over there. It's very traditional, not much Dockerized and all those things 3 years back, right? So, and domain controller and things like that. So this was the initial state of it, right? And then we started deploying applications into it. We had one website, the other one, and then we put some other services into that, search, some reporting, and all those things. So it started growing up over time of time. And then, it worked nicely for some time. And then when we had a lot of users and we had a lot of applications installed into our production server, we noticed that, OK, now the performance is getting a bit affected. So obviously, what you do is you scale up, right? So we added one more server over there. We had a load balancer, typical evolution. And then it started working again nicely, no problem at all. And then, again, we had more and more websites coming into picture. And then, yes, the next step was to scale the web front end and put a load balancer over there and things like that. So if you can see that our infrastructure is growing over time, right? Typically, and it continues, and then we thought about data loss and all those things, and we had replication on the database server. We added more servers to that, and it reached something like this stage after some point of time. So this was our infrastructure. So it grew from 4 servers to this stage. It took like 2-3 years to grow into this state. Everything is fine, right? We were doing manual deployments. So we had our software packages created by the developers. We pushed it to the operations, and then they had to deploy it on the servers because they had only access to that one. Because there was a lot of software teams doing this thing. And to make the job easier for operations, what we did is that we created something called as release notes. So these were the steps, right? You just open this thing, enter this keyword over there, plus enter whatever it is, and then it was installed on the server. So it continued fine till one day we noticed that, OK, there was an error in production. So it was not like we were not testing the software and all those things, right? We were testing it in our development environment. We were creating softwares, and we were giving it to our test environments and all those things, and we were giving it to production. And there was one error or a couple of errors only in production. So how do we solve it? Because it's not reproducible in this one, right? So how do you solve these kind of errors, which is only in production, not in development? How do you find it earlier?
Nobody has experience with production errors here? Are you all so supreme that you can? Who had to log onto a server because there was a production server, because there was an error in the production system? Who of you has had that situation? Yeah, don't be ashamed. Everybody's done it.
We have done this thing, right? Well, you cannot actually debug in production systems, right? So to solve this thing, so we came up with an idea of something called as a DTAP environment. So you have a development environment, test environment, an acceptance environment, which is very similar to the production, and then the production environment. So we need to create a proper DTAP environment, the acceptance, which is exactly replica of the production. But we had a solution, but then we also had a problem. how do I replicate the production environment into an acceptance environment? If you look into this one, it's pretty simple, right? It's just, okay, we need to have 2 app servers, 1 reporting server, all the software installed on that server. But that was not the case. It was kind of impossible for us to do this because this system was evolved over time. It came after like 1 year, 2 years, 3 years. Different people worked on the servers, right? People who have started left the company. They don't know what they did. Some of the things were documented, some of the things were not documented. What order it was applied to, what were the updates applied to the system? Nobody knew it. So we only have a high-level overview of it, right? I'm going to show you what does it make so complex. So if you look into one of the servers, like just the web server, and you think that, okay, this is just a web server, so it has to have a particular operating system installed on that web server and some changes, right? But actually, it is a lot more. So it has to have some kind of frameworks. It has to have apples, service accounts, some permissions to that server, registry changes, files. Yeah, you can call all of them, right? Ports, everything. And these things are normally small changes that is applied to the server which is not documented. You open some ports, you apply some updates, you install some patches on the server, which is never documented. These are actually the items of complexity of the system. And you cannot reproduce them manually after some point of time.
So the evolution is actually the complexity of the environment. Like starting a new environment can be quite easy, but the evolution is what most companies have to deal with like the rest of their existence. Exactly. And that's where the complexity lies.
And what could be the solution for this one? That's where we figured out, yes, we need to do something that is not manually installing software on the server or manually configuring the servers. That's where we started automating this thing. So that's kind of the, how we reached into automation. And how we did this automation, what were the main components of it, and all those things, maybe Maarten could take you.
Yeah, so we've established that like manually setting up such an environment, especially maintaining it and making it evolve even further, is a hell of a job. So that's why we have infrastructure as code. And this is a picture of how you can define the infrastructure, like what components there are. There's your overall configuration, which is basically your infrastructure as code. And you aim that at specific nodes, like they could be physical web servers, they could be virtual servers, doesn't really matter. A node has 1 or more roles. So a role is something like a database server, an app server, a web server, log server, anything basically. And you can assign roles to a specific node or multiple roles. And within such a role, there's a resource. A resource is something like, I want you to install MySQL server, or I want you to set this registry key, or I want you to make sure that this configuration is always in place, or even something as basic as like having the proper root keys in place, SSH keys, so everybody can log into the server. All of that can be resources.
That is the actual items of complexity. That's what makes the system really complex to reproduce.
All those really small modifications, like changing a port here and there, changing a little bit of a certain configuration file, that's complex. Installing an application isn't really that complex. So you have we had the overview of the nodes, and this is how it looks in the bigger picture. There's like a programmer at his workstation, working on code, working on the infrastructure, puts the infrastructure into the version control, goes into a CI server, because preferably you want to have that infrastructure as code automatically tested. There's even options to do it test-driven, so you can have like everything covered with automated tests, so you know that when you put your infrastructure actually onto those nodes, it has a certain quality, so it doesn't break immediately. And so from the continuous integration server, it goes to the configuration management server, depending on which tooling you use. And that configuration management server is what either pushes it to the nodes in production, or like in your DTAP straight, or it functions as a point where those nodes can pull it, depending on which tool you use. There's a pros and cons for both push and pull, but in this situation, it's a push-based system. And then the users don't really notice anything. They just visit the nodes, and like they're all identical. They all have the proper configuration. So zooming into some of these components a bit more, you have like the workstation of the developer where you can create and authorize configurations. You have like laws and all these things that make our life a little bit harder every now and then, you put that on your workstation. You also have like, you define the nodes, the roles and everything. You put in configurations all on the workstation. You even manage your cloud resources, make sure like we want like 10 app servers, 2 database servers, and you configure the push configurations, like how frequently do you want this stuff to be pushed onto the actual nodes. Then onto the server, which is the configuration management server. That basically manages everything that's your infrastructure, all the infrastructure defined as code. It also monitors the other systems, so it knows like, when this node doesn't have an agent anymore, so we can't really like push the infrastructure to you. So it can even tell you that that node is down and you need to look into it because something went wrong. And it keeps a history of what happened and reports. Like if something goes wrong or something changes, some companies want to have a copy of that. And it all happens on that application management server. And then there's the actual node, which contacts the management server and like pulls the configuration or receives it, depending on your specific environment, and compiles and runs like the scripts if necessary.
Yeah, the compilation and running is also very important because that's the beauty of infrastructure as code kind of systems, right? You can write infrastructure as code in a declarative language, which is not specific to an environment. But then, based on the node, based on the infrastructure environment, like if it is a Linux server, it will compile it to that language and run it over there. Now, because we talked about it, as I said, like just have very less amount of time. I'll quickly show a small demo of infrastructure as code. I'm not going to show you a Chef or Puppet or something like that. I have a Windows laptop. So what I did is I've configured this laptop using PowerShell DSE. Does anybody knows about PowerShell or DSE? Desired state configuration.
Really a Linux cloud here.
That's a very
You're the
big
good
Linux
people.
cloud. Wow. Sorry, I'm a Microsoft guy. Well, I can show you something. Right. Boom, boom, boom.
You don't need to exit the presentation.
No, I can pull it out, right?
Right.
Oh, no, I need to exit the presentation. Right. So this is my SDK. This is Visual Studio. What I've done is you can see that sometime back, Maarten talked about configuration, right? The configuration is applied to a machine. So this is like a typical configuration file. So you can see that it applies on my local host machine, right? This is a local host machine which I'm targeting. So if you have multiple servers, you will have some kind of a variable over there or multiple server names over there where this configuration has to be targeted to. And then you can see a language which is pretty much readable. It's not like scripting language or something. It's very declarative. So you can see that these are the resources which we're talking about. These are the items of complexity which you don't actually document. So you can see that I have some registry changes over here. I have some policies to be executed on the machine and things like that. So each of them is pretty, straightforward. So you can see that if it's a registry, it applies that, and this is very important, ensure equal to present or absent. So you can switch it off and on by changing that flag. If you don't want that to be installed, you can just say it's absent and run this one, or push it to the server, and this will be executed over time. It's a big file, so I'm not going to go through all of them. What I'm going to do is also show you something. I'm gonna do something. I have Fiddler installed on my machine, right? What I'm going to do is I'm gonna uninstall this one manually from my machine, and I will show you after I run my configuration, it automatically installs it. I do have internet, so I don't have to worry about it. So let me just uninstall it.
This is actually the manual part you only have to do if you're not running it with your infrastructure as a code system. So if you run the infrastructure as code and like change it in the source code, it can do it automatically without any need for interaction whatsoever.
And I'm going to search for Fiddler, and you can see that it's removed from the system. So it's not there anymore. What I'm going to do is I'm going to show you something in my code, which is here. Probably I can see, so I can see that a fiddler is required over here, and it says that it should be present on the system. So if I run this configuration, this should apply the system on the state which I want to. So just gonna run it out. It takes some time to boot it up, and then it should go. And actually it does a couple of things when it is running. It always checks whether the system is on the state which I want to. If it is not, it is going to report me that, okay, this thing is not present on your system, I'm going to change your system. So you can see that, it's always a test there. You can see that it's testing it over there, and it's a set. So we'll reach the place where it's going pretty faster. So we'll reach the place where Fiddler is. It's testing Fiddler. Come on. Go,
Should
go,
be
go.
any time right now. Yeah, there
so
it goes.
it's now testing Fiddler, right? And it's saying that the package is not installed on the machine. This will be installed. So if the test is failing, it's going to say that it's going to install the software on the machine. And then it's probably installing it now. So
The same thing works if a configuration file is changed. Somebody has added an option. It can just put back the configuration file to the exact state you want it. It's like optional. You can either have like replace lines, pretty easy, or like have entire configuration files in it.
So now it says that it has completed it. So let's see whether Fiddler is installed over there. And now if oops, yeah, it's back.
And Fiddler's back.
So this is how it works. It keeps on checking the system. I've configured it to automatically check every 15 minutes. So every 15 minutes it's going to do these things. I've done it manually now, but this is automatically done. So if somebody has changed your system, it's not going to allow the system to be changed mode. Every 15 minutes, it's going to come up. It's going to check whether the system is in the state it wants to, and it's going to notify. It's going to log this event that the system was not in the desired state, and then it's going to change it to the state which you want. So if you want to do something onto this system, which you want to change it, there's only one way to do it. You have to code it.
Otherwise, it's never going to happen.
And it's very easy for me, right? This is a company laptop, so if it is crashes or something like that, I don't care. I just get a new laptop.
Move on to the next one and just run this.
Exactly same system, I get it.
It's pretty easy on a local laptop, but I guess you can imagine right now how powerful this will be in a real big environment with lots of servers. So that's infrastructure as code, guys. Are there any questions? Yeah?
What about the installing software, let's say? If I install some crappy software, what about uninstalling software?
This is basically infrastructure, right? Software installations, infrastructure as code is the concept where if you create a software, the software should be responsible for configuring the infrastructure which it belongs to. So this kind of code goes along with your software package, and this gets executed by a server, infrastructure server, which is going on, and the software normally gets installed through a pipeline or something like that. So I push my infrastructure and the software through the pipeline. So before the software gets installed, so if you have a pipeline, you do some checks in the pipeline before installing the software, right? One of the check, it's a pre-check, is to check whether the infrastructure is ready for the software in the state it wants to. And that's what this software does, this thing does. If it is not ready, it's going to fix it for you, and then the software is installed on the machine, and then comes back again.
And if you install something on the side, like somebody installs an application that shouldn't be there, you should have like a defined list of what should be on the system, and anything that isn't, that is on the system that shouldn't be, that's not in that list, you can configure your code to just remove that piece of software.
Yeah.
So,
Is it technically possible with this toolchain?
Yeah, this is basically, actually this is PowerShell. And this is very much configurable. So what I have done behind the screens is, oh my, where is the mouse? Okay. This is the configuration file, but also there are some kind of modules which I've written to do these things. You can create your customization on of that. Microsoft has provided, and the community has provided a lot of resources which is out of the box available to do the stuff which is common for all of them. But if there is something specific to your software environment and which is not available in the community or from Microsoft, you can create it. It's pretty easier to do.
it's just code, basically.
It's just code.
Yeah, you can even hook up a bash script to this. It's
Yeah.
a bit of it's not the prettiest solution, but it's a solution nonetheless. Yeah.
Any more questions? Nope.
We're here the
Okay.
rest of the day, so if any
there's
questions
one there.
pop up,
In the back,
there's a popcorn stand.
Yes.
Ah,
Yes. Catch.
ouch. We have
didn't
one
catch it.
participant less.
No, I wanted the mic.
Well, there's a mic in
It
the
is a
box.
mic.
Wow, awesome. This is
That's
great.
why I
It's
wanted
pretty
to
cool,
use
right?
it.
Okay, so I want to ask a question because when you automate infrastructure like this, there are things that are like sensitive information that you cannot put into version control. So how do you handle passwords
Exactly.
and machine-specific sensitive information?
There are solutions for that, and it's very tool specific. I know that Ansible has something to encrypt that information and decrypt it once you start running it. So it's not like visible to all developers. Not sure about PowerShell DSC and Chef. That's
It's the same thing.
area.
What we do is, for example, to name it exactly, we have something called a zygotic secret server where we store all the passwords. And the access to the passwords for specific environment is given to some accounts only. So the developer environment passwords is accessible to all the developers, but the production server passwords are not accessible to the developers. And based on the node which executes this configuration, that node runs this configuration under a specific account which has access to that passwords only. So we create resources to access the secret server and get the password from there.
You're using central server for passwords?
Yes, we use a secret server. Yeah, it's a software called a secret server. You can use any kind of software to manage all your passwords in your infrastructure as well.
How do you handle the single point of failure?
It's
Replicate.
yeah,
the server.
it's same. Yeah, it's a big software provider, so they have all these things considered. It's a master-slave system and things like that.
And we can do that because it's written as code.
Yeah.
So, yeah. It's easy enough.
That's good. Thanks.
Yeah, no problem.
Welcome.
Okay,
can
before
throw
we
it
go
back.
to the next question, we found a 16 gig micro SD card somewhere on the floor. So if it's yours or you like to live on the edge and plug in unknown cards, it's in the back near the camera at the social media guy. And any other questions also in
Yeah, well, was a question over here. Yeah.
right here? Watch out.
So, to get this, so to get this infrastructure as code and resources, I think there is software that supports your process. But what is the software, and is it open source or is it just internal?
Like to do this stuff, you mean? Like to do infrastructure as code, to run it?
Yes.
Yeah, there's open source and closed source software for that. Big names are, well, PowerShell DSC, Puppet, Chef, Ansible. And Ansible is open source. I don't
Everything is
really
open
know
source.
about the
PowerShell
other-
DSC is native Windows software, so you don't have to buy anything from there, just PowerShell.
You
If
can
have
buy
installed,
stuff, of
install,
course, but
it's there. Chef and Puppet and everything is open source, unless there is a paid version for it also, because there are some benefits of getting to the paid version, because then you can maintain the server in your infrastructure. Yeah, there are plenty.
I can
of them.
give you the names
Yeah.
of some of these pieces of software.
Okay, thanks.
Yeah. All right, any other questions? Now, if you have any other questions, like I said, we're at the popcorn thing machine at the end of the hall over there. So if you fancy popcorn or anything else, just walk over there. And thank you for your time. Have a nice day.
Thank you, guys.
Thank you, Maarten. Prajeesh.